开始老师您好然后各位知识寻求者大家好今天我上来是给大家分享一下我的压缩机系统及能量单元，我做了一下改动。
你直接分享屏幕吧。
我看一下。
He said he's trying to share his generators. He made some changes to it.
Okay, I've asked him to start the video, so see if he can do that. Okay. Oh, he's screen sharing. Okay.
这样可以吗？
可以。
Yeah, we can see. You gotta increase your picture.
放大一点。放大一点。
Yeah. Now move it up.
好，就这么大可以了。
然后我还有，然后这是展示的一个系统，然后这个能量单元呢，我进行了一个改动，然后我加了一个无线环在能量单元里面，这样的话会更好的看到单元的一个效果出来。
He said he added an infinite loop inside this Magrav unit. Maybe there is some improvement. 好，你继续吧。
Pardon? What has he done?
He added infinite loop in the center of this Magrav unit.
Yeah.
Yeah, maybe we can see some improvement.
No. There is something we have to say. I don't know if it's gone back on blueprint or not. In the blueprint, the original blueprint, there is a slight mistake. It's not a mistake, it's just the way it's been drawn, initially thought, and then it's corrected. Can we have the blueprint while you're there? Stay there. Can you bring the blueprint out, please, of Renan, are you there in the background? The blueprint has a, if you want to understand it, a connection problem or a connection adding that it is important to understand. And that is, you come from your power supply, you come to the positive of your capacitor set, and you go out to the negative of the capacitor set into the stacker unit. This is wrong. It has to be the way where you come in, you come to the center, which is a negative, and then you take from the positive. There has been a problem in this drawing. It's just been reversed. I inquired about it at the time it was put. It was said it was going parallel, and I emphasized that it was parallel, but we checked again, it is has to be corrected, which means when you come from your power supply, whatever it is, you come into the negative of the capacitor and you go out of positive. Somehow in understanding of the drawing, the picture has been turned. Please correct it in the blueprint. And this is one of the problems which we have noticed. You come in from, can I have a blueprint? Can I have a whiteboard, please? Just give me a second, we come back in again. Rick, can you give me a whiteboard? Okay, at the moment what you have, yes, it's okay. At the moment what you have is this, and it has to be checked. I hope Renan has changed it in the blueprint. You come from the power supply, positive, negative, and you go into 4 capacitors. This is the present drawing where you come this way and you take your wires from the negative and you go out. This is wrong. This has been put in wrong. It has to be this way. You come to the negative, you got your coils, and then you go to positive into the negative of the Magrav. Some of you might have had a problem with this, and so it comes in and it goes through the negative. You go to the center pole, not into the positive. Somehow in the drawing it's been turned 180 degrees. Yeah, I inquired about this at the beginning. I said, no, it's in parallel, it has to be. And now we know that it has to be changed back into the original shape, which is positive, negative. So you can power supply, you go through the plasma system, negative, positive, negative, positive, negative, positive. The what you call the structure changes quite a lot. We've seen this, and so I hope for those of you who didn't notice it, on the blueprint should be changed, and if it can be updated. You might find totally different performance from your system. There are addition to the Magrav system which we will add to the system for you to check. We have realized very recently in past, we are checking still. Arman came up with this past 24 hours, 48 hours. He has discovered there could be a possibility of error in or not getting a better performance from the Magrav system with some connections. We will announce this once we are checking in the factory. We are checking in Italy to see if this is the case. We'll inform you, and then we tell you how you can adjust it. That increases the, what you call, the potential of your system's reduction. Some of you who couldn't see a massive reduction, it could be a connection missing in one of the drawings that you have created, and it has happened in our factory production in some materials. We are checking it as usual. We are not afraid of mistakes. We are very open about it. If it is there, it has to be corrected. This is what we just noticed in past couple of days in respect the connection into the generator. Please adjust it, and if you have made generators and you're waiting for it to see how it works, the capacitor, by somehow misunderstanding or mistake in the drawing stage, has been put back to front. Remember something very important. When you make these units, this is essential. This is very important that you come from the supply, you come into the 4 capacitors, and then you go into a Magrav system. These 3 Magrav systems should not have any capacitance or any capacitor in any shape as a Magrav unit with them. They are applied on their own. I've seen some people doing this, using the Magrav system with all the capacitors in the back and the front for this purpose. This cannot be done. It has to be the stacker unit without any capacitor, because you have capacitors here. These will trigger problems in your system. The other thing, which is again with your development of the capacitors, please remember how to make these capacitors. It's important. The capacitors are made in a strict way, in a very, very specific way. You can go up to 3, maybe 4 nano if you get it the right way. Understand how it's done. It's very important, because we are still ourselves learning in this process. You have the GaNs of CO2. You may create nano GaNs of copper oxide by heating the copper wire very high, creating nanocoat, and then you dip it in a very cold water. You get this lot of sparkling and splashing of black stuff. You need that black stuff to add to this. This is a nano GaNs copper on your coils. The way it's been done, these coils are added with gel, which has in it the component of NOH. These are very little things you have to pay attention to give a very high powerful capacitors. In the background, Renan will add this to the blueprint. We are not just showing something to show. We are guiding you step by step why some of you and you cannot produce certain materials. You got to remember very clearly how you roll these capacitors. Paper, you put this on a paper, or you put this on the aluminum side, you put a lower on the paper side. You can put a CO2 with a gel, with an OH on your paper winding, and then with a copper oxide, nanomaterial, gas material added to it on the aluminum. You let it dry, that you cannot scrape it off, it joins in it. When you look at the ones which Douglas makes, they are literally as part of the metal. They fuse into the structure and they give you a very high potential capacitance. These are little things you have to do, you have to look for. Every day I sit and I learn from the teachings in the Innovation Center, and we don't pay much attention to it. But little adds to the strength and gives you what you want. Please, when you use a Magrav system, only use the coils and not the capacitors and the other one. The capacitors have to be in the right direction. When you look at the compressors, one compressor has to be much bigger, powerful than the other one. You can't use parallel compressors. And then you get your condition of flow. The compressor connection is updated again because some people could not understand how it works. It's been upgraded. Please, Renan will put it up in a new version. A line which was connecting the compressor into the capacitor beyond has been taken off for maximum efficiency and the connection. The new version, the new upgrade diagram for Magrav has been set. Please check it. If you build one, just recheck that it goes. The ratio has to be very big, 1 to 2 if you can do. There is a thermostat controller of the current flow in some of the capacitors. Please do not take it out. We've seen it burning out and we had it past couple of days ourselves. So Renan, please update the drawing of the generator that people can check and check again. We try to be very precise in how you make things, how you develop your gas materials, and how you make your winding of the capacitors and your stacker units and how you connect it. This makes a lot of difference for a lot of you who could not get your system going. Capacitor direction has to be changed. The line between the compressor and the capacitor has to be taken out. You don't need to have capacitance or capacitors with your stacker unit. In the process of generation, you don't need that. And then what you do, you take your load across out as it should be.
May I ask a question?
Yes, we still with our Chinese friend are in the queue. Can you wait?
Yep.
Thank you very much. Go ahead, Rick. Can we go back to our Chinese colleagues, please?
Mr. Keshe.
Yes, Mr. Armand.
There is one more thing, you know, that you have a.
Can you speak louder, please, Armand?
You have to connect backwards, you know, in a drawing, you have to add one more thing, that the negative side, it has to connect the capacitors together.
Yeah, they are in parallel.
Yeah, with the stacker.
Pardon?
With the stacker, they are in parallel.
No, they are not. It's not. That's the problem. It has to be turned the other way around. They are not in parallel. The capacitors are in series with the stacker. In the drawing, it's a mistake. The 4 capacitors are in parallel with each other, but they sit in series with the stacker unit.
Yeah, the 4, actually, the 4 and 4, they are in parallel.
And we have only one set of 4.
Okay, one set of 4. We
Yeah.
are putting 2 sets of 4.
You can do 2 or you can go to 12 to increase the power supply. In the very near future, we are testing things in the background that we can show you. You can produce huge amount of power out of these systems. But let us do our work. Literally off the board understanding is passed the knowledge on. And we have seen other testing going on, other development going on. We are reconsidering the position and connections of the capacitors and the rest.
Okay,
Can we
perhaps,
go back to the Chinese, please?
Sure. Bob, can you ask 1, 2, 3 what to do there? He wants to share again, I think.
OK，你可以再共享一下屏幕了，还在吗？
在的。
OK, he's sharing again.
Okay, carry on.
继续吧。
我的电容，我刚刚看一下，我的电容呢，确实是放在能量单元的中心的，然后电容正好也是串联的。不过不知道，我看你打的字，我不知道是不是这样的一个情况。
它不是在它中间，那个是串联的，但是它是4个并联在一起，然后串联在能量单元和它串联在一起的。
对对对，我是串联，但我的电容也放在了能量单元的中间，正好是替换的，就是干丝球。
哦，这样是吧？好，那我问一下他这个。And he said his 4 capacitors is in the center of the stack unit, in the place of the GaN spoles. So
why not? If he works and it gives him a response, why not? We learn from them.
No, it's not working up to now. He said when he switched it on from A to B, he saw some sparks on the switch. So
no. What is it connected? Is it connected to a battery or to a grid?
他问你是怎么连接这个？是用市电启动的，还是那个用它的那个电池启动？
市电启动的。
哦，用市电。He said he connect to the grid. Yeah.
Yeah. Then when it switches on, you take the grid off, and it's just a start.
他说你市电切换。
You have a potential difference. You see the energy release.
他说电势不一样，你这样切换的时候是有火花，这样。
我是用那个。
直接问了我火花的问题。
我是用的那个船型开关嘛，它就是直接切换的时候那边市电是断开的嘛，然后这头它直接就接触，它接触的时候那边是完全断开的。可以看一下吧，要不我把船型开关给你知道吧？应该我可以给你看一下。
你看一下吧。
What energy do they get?
I'm sorry? He's showing the switch. I don't know what the name is.
Tell him to move to the right. It's come too close, we can't see anymore.
往右边挪一点，你要保证桌子在那个摄像头中间。
Maybe he can turn the camera down, so I think that's what he's going to do.
Yeah.
Yeah, you were right, Rick. What is there? There's a drill?
有个电钻嘛，他说。
Compressor.
那个是这个吗？
这是绕线机。
是那个绕线机。
哦，绕线机。It's for winding coils.
这个就是个船型开关，这边切换的时候，它另一边是完全断开的。
exchange switch is that when switch to the other side is the first side is completely disconnected. So there isn't any problem on the switch, Mr. Keshe.
Okay, thanks very much. But that's the two compressors look to be the same, equal, and it will have a problem.
他说这个两个压缩机是一样的嘛，这样就没有电势差是不行的，必须要一个大一个小，一个强一个弱。
对的，就是一个大一个小的。
Is that it's different? They're different.
They're different. Okay, no problem. But ask him to look at the blueprint. Hopefully, Renan will put it up today, tomorrow. This is an update on the what do you call the generators. They need to be adjusted on the drawing.
Okay.
Is Douglas in the background? Can you see Douglas? Or he's not there?
Uh, 他说，开始先说你这个之后要改善一下这个连接方式，然后之后那个瑞尼会改一下蓝图的，所以现在你启动不了也比较正常吧。OK。
然后还有其他的什么吗？
I don't see Douglas right now, Mr. Keshe.
He's not there?
I don't think so.
Don't think so. He must be asleep. Please. Can you go back? Somebody made a comment. What was that comment? Who made that comment? Can you see with the last comment which just came up on the Zoom chat?
Mark Herb says, is Mr. Keshe dyslexic?
I don't know. You come and check. Never been one. Can you delete him, please? Take him off the chat. Don't let him back in. Okay, go back. We don't need trolls. Just delete him up. Don't let him back in ever. You have to allow the system to reset itself. You have to allow the system to operate in a new manner. And something which we notice in different experiments is that how you position these two compressors will affect the performance of some of the systems. We are trying to replace the compressors with solid state. We are testing in different ways. So when you work with these compressors, even with what we realize, the positioning of the system, Magrav systems into the compressors can and could have effect on the performance. Any other question?
还有问题吗？
可以问一个，这个，请凯史老师看一下我这样的无限环，如果我不断的往外加，就是说1、2、3、4、5、6啊，这样不断的往外加，这样是否可以？
是什么意思？不断往外加？
就是说无限环。
我知道。
这1、2、
excuse me, is this the stacker unit? A stacker 1, a stacker 2, a stacker 3?
No, this infinite loop. Can we add more loops outside the smallest loop? 1, 2, 3, 4, 5.
Why not? It could be beneficial.
他说可能也很有效。
这种是可以的，是吧？
可能比较有效，他说，有效的。
是。好，谢谢。
Yeah, thank you, Mr. Keshe.
Thank you very much. There is nothing wrong. You open, you're the frontier runners of this technology. You try, you tell, we see, we learn.